Now, in this video, we will see about how to get AP data from users. For example, while writing the programs, if you define data along with programs, there is no problem. It will accept data automatically and it will do computations. For example, if you want to get data from the users through the Windows, for example, enter the first number, enter the second number, enter the third number. That means you are asking or requesting data through some output screen. That means it is asking input data through the output window. For example, enter the first number means user will enter some numbers. Similarly, if user want to enter second number means just you want to type this to enter second number. So if user enters the number through keypad, it will not come as it is. So the number will be converted to ASCII, and this ASCII number will be applied to the processor to process the instructions. But while if you use ASCII equivalent number, the processor means this will, if you apply the ASCII equivalent number as input to the processor means it will not easy to process the data. So you must need to convert that ASCII equivalent number to the original number. For example, if you apply 23 as input to the processor, input through keypad means the keypad will not give 23 as a number to the processor. It will give only the ASCII equivalent for 23. So we will need to do some computations or operations to get the original number. And we need some set of instructions code and set of programs to convert the ASCII equivalent of the number what we entered in keyboard to the original number. So in order to do that, we will need to use some set of instructions or codes in 8086 along with the original program. So this code we must need to use along with the original program to add, subtract, multiply, divide, any operation you will need to do. In order to fetch data from the users, you must need to use the set of codes along with the original program to get data from users. Now we will see how to get data, how to convert the ASCII equivalent of the number what you entered in the keyboard to the original one. That we will discuss now. For example, now I want to perform two 8-bit addition. So I need two 8-bit data. For example, if I enter the value for first number as 23H and B as 1AH. So I want this data from user side through a keyboard. But keyboard will give only the ASCII equivalent for 23, the ASCII equivalent for 1A. So in order to convert the ASCII equivalent produced by keyboard to the original number. Original number what we require is 23H. The same number what we required to do instructions. So when you enter 23 in keyboard, this will give the ASCII equivalent for 23. But the processor will not use ASCII numbers to process the instruction. Convert the ASCII number again back to the original number 23. We need to use some set of instructions. That instruction we will need to use along with the original program. So inside the original program, we will need to use this set of instruction to get these two 8-bit data from the keyboard. Similarly, this number also convert this key when you enter 1A in the keyboard, this will give only the ASCII equivalent number. To convert this ASCII equivalent number again back to the original number 1AH, we will need to do some set. We will need to use some set of instruction. This instruction we will need to use along with the original program to process the instruction. Now I will tell how to convert the ASCII equivalent of the number. So that we get from the keyboard again back to the original number. We have some process available here. I will explain one by one. So for example, first example, I am taking the variable a with a, or first variable with number 25. So if you enter number 25 in keyboard, mean this keyboard will give only the ASCII value. So the, for example, this ASCII value for 2 here is 32, ASCII value of I is 35. If you refer the table, this one is ASCII value of 2 is 32H, ASCII value of I is 35H. This will give the ASCII equivalent number for 25, 32, 35. In order to convert this ASCII equivalent number again back to the original number. So original number what we require here is 25H. This number, that we entered in the keypad, that number we will require as it same number that we require as output. But when you type number 25 in keypad, this will give only the ASCII numbers to the processor. To convert this ASCII number again back to the original number, we will need to follow these type of steps. We will need to use this set of codes. This set of codes we will need to use along with the original programs in 8086. These are all the we call this as a this set of codes we will use along with the original program to get AP data from users through keyboard. So if you want to apply this 25 8-bit number to the processor, means we will need to use this instruction to convert the ASCII number to the original one, because the keypad will give only the ASCII equivalent number. That number we will need to convert into original number with 8-bit form. So in order to convert the ASCII number to the original form, we will need to follow this set of instructions. This set of code, first set of code is used for converting the higher byte of the ASCII to the original number. This set of codes, the below set of code, is used for converting the lower byte of ASCII to the original number. I will tell how to convert. So after converting the higher byte of ASCII, you will get one results. So after converting the lower byte of ASCII to the number, you will get one results. Finally, we will have the results of higher byte along with the results of lower byte. We will get the original number. I will tell how to do this operation, this set of operations. This set of codes is used for converting the higher byte of ASCII to original number. This set of codes are used for converting the lower byte of ASCII to the original number. I will tell how to do that. These two instructions you know already. I explained in Interrupt 21H video session. So if you use move AH,01H INT 21H, this instruction will returns the ASCII equivalent of data in AL register. This instruction will help you to store the ASCII equivalent of number in AL register. Consider the ASCII equivalent for 2 is 32. ASCII equivalent for 5 is 35. The first, if I mention move AH,01 ENT 21H, this instruction will help you to get data from the users. I already told, if you want to, if you request any data from users, this instruction will help you to get data from the keyboard. So this instruction, after getting the data from the keyboard, this will give the ASCII numbers. This will not give the original number 25. This will give only the ASCII equivalent number for 25. The ASCII equivalent number for 25 here is 32, 35. First, we will need to store the higher byte of the ASCII equivalent of 25 with the AL register, and the lower byte of ASCII equivalent number of 25 with the AL register. First thing you will need to do here is, first we will need to process the higher byte. Then after completion of processing of higher byte, then we will need to go to lower byte. First, see how to convert this ASCII number, higher byte ASCII number, into the original one. First, this instruction, this first set of instruction is used for converting higher byte of ASCII to original one. First instruction is what? Subtract AL, comma 30H. You will need to subtract the value of AL with minus 30H. Now the higher byte of the number is ASCII number is 32. So you will need to subtract AL, comma 30H. That means now the AL is 32 minus 30. You will get what? You will get 2 as the result. The data will be stored in AL register. What is the meaning for sub AL, comma 30H? This will subtract the value stored in AL minus 30H. After subtraction, the result will be stored in the AL register. Now, after subtraction, the value here is 02. It is stored in the AL register. What is the second instruction? Compare AL, comma 09H. So now the value for AL here is what? 02H. This number will be compared with 09. So if the value of AL is lesser than or equal to 09, this will compare. Now the value for AL is 2. Now it will compare with the 09. AL is lesser. What will happen? This will JLE. It means jump with less than or equal. That means the value for AL will compare with 09. If the value for AL is lesser than 09, this instruction will jump directly to subroutine G1. Here we use JLE G1. That means it will check with the less than or equal to. If AL is less than 09, it will jump directly to the subroutine GL without executing this instruction. So now the next instruction it will execute here is move CL, comma 04. This will assign the value for CL register as CL equal to 04. Next instruction is what? Rotate L. Rotate L means now the value for AL is 02H. Now rotate the value 02 with rotate towards left, 4 bits left. Convert the number 02 hexadecimal to a binary form and rotate this number towards left 4 times left. If you rotate this number 4 times left, what you will get? You will get the number as 20H. This number will be moved to this place. This number will go to this place. If you convert this number into a binary form, rotate the result 4 times towards left, you will get this result as 20H. And then store the result in AL register. AL register. Is the meaning for rotating. After that, store the result in AL register. And then what is the next instruction? Move CH, comma AL. So after rotation, we will get result for AL as 20H. Store that result in move CH, comma AL. Now the value for AL here is 20H. The data will be moved to CH register and stored. Now the value for CH here is 20H. This is the way how to process the higher ASCII byte of number 25. Now after completing this set of instruction, the set of computations, now we will need to go to the lower byte. Lower byte, the value here is 35. So move AH, comma 01, INT 25. If you apply 01 value to AH register, INT interrupt will perform some specified function. The function that performed by interrupt 21 here is this will store the ASCII equivalent of data in AL register. The ASCII equivalent of I here is 35. This will be stored to the register AL. What is the next step we will need to follow to convert lower ASCII byte of number 25 to the original one? Then subtract AL register with 35. What it will do? Subtract the value for AL with 30H and store the result in AL register. Now see here what is the value for AL here? AL is 35 here and subtract the number with 30H. You will get the result as 05H. This will be stored in AL register. So what is the next step we will need to follow? Compare AL comma 09H. Now the value for AL here is 05H. 05H is lesser than 09. What it will do? So then are equal to 09. So JLE means jump if the value for AL is lesser than equal, L means lesser than, E means equal. The value of AL is lesser than equal to 09. It will move to subroutine G2. It will move directly to G2 and it will perform this instruction add AL comma CH. AL is a register which will hold the results of lower byte ASCII value result. But what we entered in the keyboard. So the thing here is, I think here is if you enter 25, this will not give the number 25 to the processor. This will give only the ASCII values. To convert the ASCII number to the original number, you will need to convert the number. You need to process the higher byte of ASCII first. Then we need to process the lower byte of ASCII. So now we will see how to process the lower byte of ASCII of the number 25. So the ASCII equivalent value for 5 here is 35. Already I explained this thing and just this is the way how to convert. So next number is B. As in this, I am entering the 1A in the keyboard, but the keyboard will give the ASCII equivalent for 1A. To convert the ASCII equivalent number of 1A to again back to the original number, it is 1AH. We use some set of codes. What we used now, the same set of codes we will use here. But there is some differences available. Here we use number, we here use only the numbers. But value for B here is value for B. Second 8-bit input contains numbers as well as alphabets. If the second 8-bit number contains alphabets, we will need to do different set of procedures. See here, if the 8-bit data contains alphabets, just get the ASCII equivalent for A, subtract 30, and then subtract one more times 07. You will get the original result value. Now I will tell how to convert. So if user enters 1AH in the keyboard, but keyboard will use only the ASCII value. Here, if you enter 1A in the keyboard, but the keyboard will use only the ASCII equivalent value for 1A. So the ASCII equivalent for 1A is 31. Therefore, the ASCII equivalent for 1A here is 31. ASCII equivalent of data in A register. This will simply copies the ASCII equivalent of higher byte higher byte to the AL register and the ASCII equivalent of lower byte to the AL register. First it will process the higher byte, then it will process the lower byte. First I will see how to process the higher byte. The first instruction we will need is this set of code is used for processing higher byte of ASCII. This set of code is used for processing lower byte of ASCII. ASCII. First instruction we will need to do is subtract AL comma 30H. Get this data from AL and this one is AL, subtract with 30, you will get 31 minus 30 as 1 and store the result in AL register. What is the meaning for subtract AL comma 30H? This will subtract the value stored in AL with the 30H and store the result in AL register. So after subtracting, the value stored in the register here is AL. What is the next instruction you will need to do? Compare. Compare AL comma 09. What is the value for AL now? Result after subtraction. There is 1H. This value will be compared with 09 by using this conditional jump instruction. Jump less than or equal. So the value for AL, it will check. Value for AL is less than or equal to 09. 01 is less than 09. So this condition satisfies. This will execute this instruction. It will move directly to the subroutine G1. If you use jump less than or equal to me, this will compare the AL with 09. If the value for AL is lesser than or equal to 09, this will go directly to subroutine G1. This will what it will do, move CL comma 04. The CL is a counter. This will store the count value 04H. Now the CL here is 04. Now what is next instruction it will do? Rotate left. This instruction rotate AL comma CL. Value for CL here is 04. So now what is the value for AL here? 01H. This 01H, write the binary equivalent for this number and rotate this binary number towards left 4 different times. Once you rotate this number towards left 4 different times, you will get this number. 10. This any 8-bit number, if you rotate towards left by 4 different times, this number will go to this position. This number will go to this position. The value you will get here is 10H. This number will go here. This number will go here. The output results you got here is 10H. 10H. This is stored in the AL register. So see here ROL AL comma CL means CL is 04 and the value stored inside AL will be rotated 4 different times and stored the result in the AL register. Now what is the next instruction? Move CH comma AL. The value stored in the AL now move to the CH register and store in the memory. Now the value for CH here is value from AL. That means 10H. Then after processing the higher byte of ASCII value for number 1A, now we will going to process the lower byte of number 1A. So the ASCII equivalent for A here is 41. If you enter this two instruction, move AH comma 01, INT 21. This will returns the ASCII equivalent of data in AL register. This will move the value 41 to the AL register. And then second instruction is subtract AL comma 30H. This will subtract the value for AL. The 41 is the value for AL. This will be when we subtract this value with minus 30, you will get the result as 11. 1 minus 0, 1, 4 minus 3, 1. Now after subtraction, value will be stored in the AL register. Now the value for AL here is 11H. What is the next instruction? Compare AL comma 09H. Now the value for AL here is what? 11H. The value for AL is 11H. Compare AL with 09. Which one is greater? AL is greater. So this instruction is not valid. This condition not satisfied. When this condition satisfied, if AL is less than 09, see here L means less than, E means equal. If AL is more than 09, this will not execute this instruction. It will go to the next instruction. Subtract AL comma 09. This will subtract the value for AL with 7. Now the value for AL is 7 level here, level minus 7. You will get the output as 0A. 0A. Okay. Okay. I already told how to subtract hexadecimal numbers. If you subtract level with minus A, the output here is 0A. After that, what you will do? Add AL comma CH. This will add the output results of lower beta passkey. Lower beta passkey means the value for lower beta passkey is stored in AL register. The value for higher beta passkey is stored in the CH register. Finally, we will add the value for CH. That means higher beta passkey is 10H, lower beta passkey is 0A. What is the final value? 10H plus 0AH. You will get the output as 1AH. This is the original number what we entered in the keyboard. Once these two numbers are satisfied, this data will be moved to the processor to process the instruction. Finally, first number we entered here is 24. We convert this into keyboard use ASCII equivalent. We convert this ASCII equivalent again back to the original number. Once the match is found with the original value, this will be applied as first input. Similarly, second input is 1A, but keyboard use only the ASCII equivalent for 1A. So after converting the ASCII equivalent number into original form, this will compare this value with the value what you enter in the keyboard. Once these two numbers are equal, this will be applied as second input to the processor. Once all the conversions are done, it will start processing the instruction. That is the meaning. So this set of program to process higher byte, to process lower byte, this set of codes you will need to use along with the original program to add, subtract, multiply, divide, finding the largest number, finding the smallest number, add a series of numbers. For that program, you must need to use this set of codes to get data from the users through keyboard. So while discussing the programming, I will tell where we use this code, how to get data from users. Move AH, 01H, INT 21. This set of code is used used by software programmer to get data or characters from users through keyboard. So if you want a string input from users, you will need to use this set of codes before writing the programs. Move AH, 0AH, LEA, DX, string, INT 21H. So this will load the offset address of string to the register DS. Offset address means data stored. For example, string means some characters. Some characters are occupied some locations in memory. So if you want to access all the strings one by one, and that offset address will be assigned to DS register. If you increment DX register one by one, all the characters inside the string we can able to access. That thing will be done by this instruction. If you want to give input to the if you want to give input as if you want to give string as input to the user, means you will need to use this set of instruction. So if you want to display characters on the output screen, means you will need to use this type of codes before ending the program. If you want to display a string as output on the screen, you want to use this set of instruction, like what we used for C programming. If you want to print some data in the output screen, means you will need to use printf, scanf. Likewise, in 8086, you will need to use this set of codes to request to enter data from users or to display some strings or characters in the output screen. This set of codes we used to terminate the program in 8086. So after completing all the program codings or instructions, you will need to enter these three different lines at the end of the program. telling the microprocessor that the instructions are over program. To inform microprocessor to end the program, terminate, we will need to write these three set of lines. To inform the program is over, we will going to terminate the operation. Nothing will be informed by these three different lines through interrupt command. Okay, the concept is clear. Next class, we will discuss about how to write program to exchange data, how to write program to add to 8-bit data, how to add a series of numbers. If you have 6 number means how to add all the 6 numbers and store it in registers, and how to find largest number, how to find smallest numbers. All these things we will discuss in next class using softwares. The software I plan to use for this course is EMU8086. So open source software. You just Google it. The name called EMU8086. You will get a software. Just download in your system. We will discuss next class about how to program, how to exchange data, how to add to 8-bit data, how to find largest and smallest numbers, how to add series of numbers, all those things. Thank you. If you have any doubts, kindly post your queries in the chat box. I will explain. Thank you.